Hello everyone, this is the first tutorial of a series Introduction to Aspen Hysys. If you do not have any experience regarding Aspen Hysys, this is the right platform for you to learn from a very basic. In first tutorial, you will mainly learn how to create a component list in Aspen Hysys, how you can select a right property package for property estimations, and then you will learn to set different preferences in Aspen Hysys. For example, different unit sets, and then we will create a flow sheet, and then you will learn how to edit the flow sheet in Aspen Hysys. Ultimately, in the end of this tutorial, we will generate results for our problem. Learning is always effective when we learn via solving problems. In this tutorial, we will try to create a flow sheet for this problem. So the problem statement is: a pipeline supplies water to a town with a flow rate of 1000 kg per hour at 10 bar pressure. We want to irrigate a fields near to the town with 30% of this water. How can we generate a flow sheet for this system in Aspen Hysys? So let's move to the Hysys software. Well, when you enter into Aspen Hysys, the first appearance of the software will look like this. These are the models on which I was working. So let's create a new case for this study. Just click on this new tab, and then you will enter into the properties environment of the Aspen Hysys. In the left hand side of this navigation pane, you can see these two tabs, component list and fluid packages, which are red. It means these two tabs are required information in order to solve this problem. These two tabs not only access via this navigation pane, but also we can access these two from top ribbon from here, like component list or fluid packages. So let's go to first component list. In our problem, only water is the main component, but in coming lectures you will see more complex problems. We have to specify all the components which will either act as a reactant or maybe produce as a product. We have to specify all the anticipated component in this tab. So to specify component, just press this add button, and then this dialog will open. In this dialog, all the available components in Aspen Hysys data bank will appear. We have to search our desired component by writing its name or by a formula like this water, and then just press enter. The selected components will come in this tab. If you select some wrong one, just click on it and press this remove. So it will automatically remove from this tab. So just press water, press enter, and then the water will be selected. Now if you observe on the left side, the component list tab is already turned blue. It means it has already provided the required information. Now let's move to the second tab, that is the fluid package. Click on this, and then this dialog will open. Now press add, and then you will see a list of fluid packages which are available in Aspen Hysys. Now question arises, which fluid package should I choose for my particular process? The right selection of fluid package is very important, because all the properties estimation will be based on the fluid package. Fluid packages are generally chosen by two ways. One is simple rule of thumb, and the second one is method assistant that is built in a function of Aspen Hysys. So I will explain you how the right fluid package could be chosen for a particular process. The rule of thumb to choose the right property package is, if you are dealing with a non-polar or a slightly polar components like hydrocarbon systems, you should choose equation of state-based property package like the Ping-Robinson. But on the other hand, if you are dealing with a polar components or your system is a highly non-ideal system, then you should choose one of the property package from activity models like NRTL, which stands for non-random two liquid models. On the other hand, if you are dealing with ideal mixtures at a low pressure, you should choose from property package from vapor pressure models like Antoine equation. Here I want to specify one more thing, that is each and every model has its specific limitation to apply for a particular system. For example, temperature range and pressure range. As an example, you can see the Ping-Robinson model can only apply for a temperature range which is above minus 271 degrees C, and pressure range, the pressure should be less than 100,000 kilopascal. So this is just the general rule of thumb to select a property package. Now we will move into Aspen Hysys environment to see how method assistant can be used to select the right property package for our process. So let's move to the software environment. Well, now we are in Aspen Hysys environment. So as I already said, these are all the listed fluid property packages in the Aspen Hysys. So now we will select the property package using the method assistant. So just click on this tab, method assistant. This dialog will open. Just go to the next. Now here you can specify your system either by component type or by process type. So we specify our system by component type. Click on it. Okay, so should our components are chemical system, hydrocarbon system, or special system like water only. So our system has only water. Just click on it. And now amine system, glycerol system, and then go again water only. Select this one. And now Hysys is proposing we should choose either ASME steam or NBS steam. There is another helpful tool that if you want to read further about fluid packages, you just simply click on this. Then it will open the help dialog in which you will have all the details for each and every fluid package. Just go through this. It is really a useful learning resource if you really want to learn deeply about the fluid packages. So you can go here. So now we are going to choose ASME steam for our system. So just select here, and then you will see the property package. The OK button is already turned green, and the left hand side the fluid packages is already turned blue. Now the property environment is already selected. It is okay. Now we are ready to go to the simulation environment. Regarding these four tabs that are petroleum assays, reactions, component maps, and user properties, I will explain all these in coming lectures where we are explaining reactors and distillation columns. These are the tabs for advanced studies, not required to explain at the beginning. So let's move to the simulation environment to create our simulation. Just press here, simulation. Well, now we are in simulation environment. So this is the tab that has all the unit operations like distillation, columns, pumps, reactors, and instrument adjustments, recycling. So all the things are available here. We have to select a unit operation. For example, we are going to define a stream that has a water, that is a material stream. So just come here. So this blue arrow, if you see, you can say it says material stream. Just click on it, and then again right click of mouse into here. So we selected material stream for our flow sheet. Just cross this one, and if you reopen this dialog, simply press F4. It's a key for this shortcut. So we will have again this dialog open. Double click on this stream, then this dialog will open. So first we change the stream name. Double click here and then say water in. So this is the stream name. So now we have to specify either temperature or pressure, or temperature or vapor fraction. As maybe you remember our problem statement, we have only water that is flowing through a pipeline at a pressure of 10 bar. So simply just write here 10, and temperature was 25 degrees C. So these two are specified. And what was the mass flow rate? It was 1000. So just write 1000. Now it says, yellow tab says unknown composition. So now we have to specify composition. Just go here in worksheet condition, properties, and then composition. Select this tab and edit it. Now we have only water. And what is the mole fraction? Because only water, just press 1 and then press OK. Now you can see it is turned green. It means our material stream is already been selected, fully specified. Now the second thing was, we are splitting this water stream into 70% and 30%. 70% for the town and 30% for the irrigation field. So just again go to the left side of the left top side and click streams and models, or press F4, and then this dialog will open. Now we have to choose a splitter, that is here. Just press it and then press it again here. Close this one. Double click on this. Now what is our inlet? Inlet is water in. We select it. And what is our outlet? So we can define outlet even from here. Just write here water to town, and the second one is water to fields. Okay, so here you can see it says unknown split. So just go to the parameters and split ratio or flow ratio we have to specify. So we know that in a problem statement we are saying that 70% of the water is going to the town. So just put here 0.7 and then it is already be solved. Well, the problem is solved in Aspen Hysys. Now the next objective is how we can edit the flow sheet and how you can select different unit set for your calculations. For that, you simply go to the Home tab and then select unit sets. Then this preferences dialog will open. In HYSYS, you can see all available unit sets, that is English units. Here they are called field, System International units and Euro System International units. HYSYS gives you freedom to make your own custom units for different properties, and you can save it in any name here, and you can use it for your calculation later on. For flow sheet editing, for example, I want to put a table, property tables for this stream water in. Just right click on the stream and then press show table, and a table that has important properties of the stream will appear here. Similarly, we can draw tables for other two streams. Show table, press right press, and then show table. So we have table for all our streams. The main objective of the problem was to split total mass flow rate of inlet stream into two, that is 70% to town and 30% to field of 1000. So you can see here 700 kilogram per hour water is going to town, and 300 kilogram per hour water is going to field. So it's a quick way to see your results. So now if I want to edit this text, for that just go to the format and say select this one, and you can change color and the font size. For example, here is 12. I just want to have maybe 14. Well, to edit this flow sheet, just simply go to the format tab, and then for example I want to lower the font size of this table. Click this table and then lower its size, maybe 7. Now it is more like fitting with this line. Similarly, you can do for the other two tables, 7 for this field and for this table as well. So just press 7. So okay, so here we have another option. For example, if I want to write some comment or the title of this flow sheet, just insert a text and click here and write anything, any comment, whatever you want to write. For example, we write here first problem and then press OK. You can write anything, whatever you want. So this is the basics of editing the flow sheet. Now the last thing, how we can generate results. For result generation, for example, if you want to print only the flow sheet, just right click anywhere in the flow sheet and then print PDF. So and write the name. For example, we say first problem and then save. The flow sheet in PDF form will be saved. So this is our first flow sheet, only the flow sheet. Well, if you want to create a complete report of this problem, then just simply go to the Home tab and click Reports, and then this dialog will open. Now if you want full reports, stream reports, only heat profile, so whatever you want, just click one of them and then create and print. So just write the name of these files. We say first, and it will save at desktop. After that, just close this tab So this is the complete report of our first case. It shows all the important properties, mass balance, energy balance, everything you want. So that's it about the report generation. That's all for the first tutorial. I hope now you are able to create a component list, to choose the right property package. You can now set the desired units. You can create now a flow sheet in Aspen Hysys. You can edit it. I hope you like my video, and if you think that this video make any difference in your knowledge, please like my channel and subscribe it. Thank you very much. See you in next video. Bye bye.